Welcome and thank you for joining ASF Surveillance and Modeling webinar. Before we begin, please ensure you've opened the WebEx participant and chat panels by using the associated icon located at the bottom of your screen. Please note that all audio connections are muted at this time, but there will be the opportunity for Q&A at the end of today's session. If you require technical assistance, please send a chat to the event producer. With that, I'd like to turn things over to Liz Fernandez. Please go ahead.
Hi, good morning, everyone. I'm Liz Fernandez with the Professional Development Services staff, and I'd also like to thank you and welcome you to this webinar today. We have two speakers for today's webinar. Dr. Oriana Beamer will be speaking on the surveillance portion of the webinar. Dr. Oriana Beamer is a veterinary medical officer epidemiologist on the surveillance, design, and analysis team at the Center for Epidemiology and Animal Health. She began working for the USDA in live animal import policy, permitting and negotiation services before transitioning to surveillance design and analysis, where her current focus is on surveillance evaluation, design, planning, and preparedness for swine diseases including ASF and small ruminants, primarily sheep and goats. Our second speaker is Tim Boyer, who will present the National ASF model. Dr. Boyer is a biological scientist with the Epidemiological and Economic Modeling team at the Center for Epidemiology and Animal Health, where he manages SIA's National ASF and CSF epidemiological models to support animal emergency preparedness activities. And with that, I'm going to turn it over to Dr. Oriana Beamer.
Thank you, Liz, and good morning, everybody. Welcome to today's webinar. We'll start out with the first portion on the surveillance standard operating procedures. And this is an overview of the document that was released earlier this year, kind of outlining the basics of initial surveillance in the case of an ASF outbreak. It is currently undergoing some revisions. We received some excellent feedback over the past few weeks, and we are working to incorporate that before the exercise later this month. I will say that there are some slight changes, and I'll point out where those may occur, but for the most part, the document will remain fairly similar to what was released earlier this year. So that's the information I'm presenting today. Be on the lookout for a slightly updated version coming out soon, but the concepts will still be basically the same. And I do want to also introduce Marissa Rotolo, who was our cooperator and helped develop a lot of this standard operating procedures document. We also have a new cooperator, Michelle Farr, who is helping with the revisions. So between the team of three, we've been doing a lot of work to try and address this topic for you all. So a quick introduction to the surveillance SOP. As I kind of mentioned, it's intended to provide guidance for the initial outbreak response, early response efforts, and it also briefly touches on the type of surveillance sampling that might need to be performed in order to reestablish freedom from ASF once an outbreak has been curtailed. The SOP specifically addresses how to target animals for the surveillance sampling that we propose, so I'll go through a little bit of that. I know that was one area that caused some confusion in the comments we received back, so I'll try and clarify that in this webinar, and it should be more clear in the next version coming out. And then we did look at some suggestions for sampling frequency depending on a premises designation. So these are the same designations that you use in the Red Book or in a response strategy, but there are some variations based on what type of premises we're talking about. So first, a few general concepts. As I mentioned, the Red Book or response strategy concepts still apply, so the definitions of different types of premises, whether that's an at-risk premises, suspect premises, a monitored premises, those are all the same. So we rely on that information to build the SOP from that. It is also using the currently approved sample types for the NALM labs to test for ASF. And then the SOP does touch on both the traditional zone approach as well as the network zones. I believe there's already been a webinar on that particular topic but in case you weren't able to join that, the traditional zones have been sort of laid down as geographic zones. So you have an infected premise in the middle, and then you draw circles or some other shape around that premise to designate your zones, and those have different sizes. You can see the recommendations for distances that we've given in the SOP at the bottom of this slide. And there's a difference between if the animals are strictly indoor raised in that area of the country, if there's both indoor and outdoor without feral swine present, and then if there are outdoor raised animals and there are feral swine present, we need to make those zones bigger. And that is based on some work we've been doing with wildlife services as well to try and make sure those are informed distances for the feral swine ranging distances that they can cover. With a network zone, that's more of looking at the interconnectedness of the industry. So if a farm sends their weaned animals to a different farm in another location, and then those are sent on to another location for growing out even further, that would be a 3-premise zone in the networking approach. So it's more based on those interconnected relationships between premises and looking at where the epidemiological links would be between premises to define what our zone is. So moving on to another topic we tried to cover in this SOP, when we're trying to target the samples and when a premises does not currently have disease, there's a couple of approaches that can be taken. One that we hope everybody would be doing in the case of an outbreak is doing some sort of observational surveillance on their animals. The table on the slide is one of the things that is being updated, but it's meant to be a clinical scoring guide, kind of modified from a CSF clinical scoring guide that we found in another publication. And this is kind of a way to allow somebody who's observing the animals on a regular basis to apply a numeric value to the clinical signs they're seeing. So in this table, you can see there's low scores for normal or slightly off normal clinical signs that they might observe. And then as things progress to more concerning clinical signs, the scores would get higher. For this table, we had a cutoff of approximately 12, so if an animal reached a score of 12 or higher, that would be one that should be further investigated with some diagnostic testing. And that would be an animal we would want to target with our surveillance sampling if there was a score that high. With the new table, we are putting a little more emphasis on to some of the really classical clinical signs for ASF. So there will be even higher values applied to some of those, things like a fever or really blotchy red skin would lead to higher scores as well as vomiting. And that's based on some feedback we received from veterinarians who have been experiencing the disease and seeing it move through herds over in Asia. So that was some of the really helpful feedback we received on that particular part of the SOP. So look forward to an updated version of this table coming out in the future. But again, it's meant to really help identify in a herd of animals that don't necessarily have disease yet, if there's signs that that disease might be starting to run through and which ones we need to target. So on the screen now you can see kind of the generic Cannon sample size calculator that we use across any outbreak. I'll get into it a little bit further later on, but for our initial phases, we are recommending for the premises level, so on a premise, for example, with 3 barns, we would want sampling to occur where we could detect 10% prevalence if the disease were up to 10% of that herd on the premises level. So that's the second to right for this column. for example, in a herd of 100 animals, you need to take 27 samples to be able to detect a 10% prevalence. For the zone level prevalence that we want to detect, we're recommending 1%, so 1% of the premises in that entire zone, and this would be mainly for the surveillance zone, how much we would need to sample for that. So again, if we use the 100 premises in that zone, that would again be, that would be having to do all 100 of those. And you can see as we get higher numbers, either of the population on a premise or the population within a zone, the numbers change and kind of plateau off where you get a diminishing return for additional samples. So how to actually collect those samples, especially at the animal level. This is another thing that's maybe not as clear as it could be in the current version, but will be more clear in the updated version. So to give us the highest value for each sample that we're taking, we really want those to be targeted at the animals that are most likely to have disease. So especially in the case of ASF, you see on the top left-hand side, there's priority for sampling. We'd want to start with the dead pig, which is the one with his feet in the air and X's over his eyes. Those would be the ones that you should fill a majority of your sample requirement with if you have them. So if we have to collect a total of 27 samples, as we were talking about before, and you had 5 dead pigs, for example, you'd want that 27 to start out with the 5 for sure need to be in your sampling that you take, followed by our red pig, which we're going to say is the 6th pig in this example. And for example, you might have 20 pigs. These are kind of made up numbers, but now we're up to 25 samples of the 27 that we need to collect, and that would be all the dead pigs if you had them, and then as many of the sick pigs that you have in the barn. And finally, if that doesn't make up your full sample size, we have our cute little healthy pig just sitting there, and you could collect a couple samples from them. So the last 2 in our supposed example that we're walking through here would be made up of those healthy animals that may be in an early stage of the disease but not showing clinical signs yet. However, knowing that biosecurity is important and we don't want to spread disease, the way you would go about actually physically collecting these samples on the farm is you'd try and identify how many dead and sick ones you have in advance, but you'd want to start out actually sampling the healthy ones. So the bottom on the left-hand side, you want to start out with your nice pink healthy pig and then move to sampling the sick ones and then move to sampling the dead. That way you're hopefully not spreading disease from opening up a dead pig that does actually have ASF in this case, and then walking throughout the rest of your barn and spreading that across the barn. And then on the right-hand side, we have kind of examples of the current approved sample types. So spleen on the top, tonsil on the bottom left, lymph nodes on the bottom right, and then whole blood. So another little cartoon diagram here for you just to kind of re-emphasize the prevalence we're trying to detect. We have a few sick pigs over in the left-hand barn, and this is all considered to be one premises with the 3 barns. So sampling to detect that 10% disease prevalence, we want to sample X number, depending on what that is for that farm, but trying to detect those pink pigs, or sorry, the red pigs, out of the group of pink. And then again, kind of looking at another cartoon example, but in the traditional zoning approach, we have our control area and then the surveillance zone. So in the control area, we'd be sampling all of them. And then in the surveillance zone, we'd be sampling to detect the 1% prevalence. In this cute little example, there's only 8 in the surveillance zone, so they'd all get sampled. But obviously that expands out as you get into bigger zones. So here's an overview of what's presented in the SOP into somewhat greater detail, but an overview for you. The infected zones and the buffer zones would have all the premises sampled. And then as you got out to the surveillance zone, you'd be looking at the 1% zone prevalence level. There's slightly different frequencies of sampling, at least early on, assuming a somewhat focal outbreak, and then it can be adjusted from there. And then I'll call your attention over to the right-hand column where we get to the quarantine release, so kind of the end game, because you have to start with the end in mind when you're looking at an outbreak and how we might be able to get back out of the disease and try to reestablish freedom. And there's an outline of kind of what would be done, but again, the really important part here is that during the release testing, both antibody testing and antigen testing has to take place, so that would currently be using a PCR and an ELISA, just to make sure there's no animals that have developed antibodies and look healthy or normal and have survived through the disease and could potentially reintroduce. With that, I'll check real quick to see if Marissa is on the line.
I'm here. Can you hear me?
I can, yep.
Perfect. All right. So we wanted to talk briefly about oral fluids, and before I get into this, I just want to say that oral fluids are currently being tested for validation by Plum Island. They are not an approved sample type for detection of any of our foreign animal diseases. So with that in mind, I just want to tell you and discuss what we would do if we had oral fluids validated for any of our foreign animal diseases, especially African swine fever. So what we did here is we looked at what was available for probability of detection estimates for oral fluids right now. As it stands, there's not a lot out there for probability of detection estimates for African swine fever, but there are estimates for endemic diseases such as PRRS. And so we looked at research out there to get good probability of detection estimates in order to see what we would be looking at for sample sizes. So in our different zones, we have this table, table 6, which is the number of ropes needed to achieve 95% probability of detecting at least one infected barn in a zone based on the number of barns within a zone and zone level prevalence. So you can see here that we've got how many ropes per barn you would take, what that gives you for barn level probability of detection, and then how many, what your number of infected barns in a zone would be. So what we're looking at is possibly 10 ropes per barn in a site. And I know that that sounds like a lot in order to achieve that 95 probability of detection based off of how many number of barns are in that zone. But keep in mind that the benefit of oral fluids is that they're a very low labor sample to get compared to testing serum or collecting tonsils or tissue samples, and they are an ante-mortem sample. So again, I would like to say that these estimates in this table are very preliminary. Oral fluids are not validated right now, but if they are, this is an example of what we might use if we were to employ this sample type for outbreak response for African swine fever.
Thanks, Marissa. So the last slide on the surveillance, we also took an initial look at what type of testing might be used if animals needed to move. And this was explored through an intra-herd spread model based on a moderately virulent strain of ASF and some information that another cooperator had from the Netherlands. And you can see kind of an outline of what we had proposed as the sampling scheme with daily active observational surveillance going on for the group that was going to be shipped, and then trying to detect a 5% group level prevalence and collecting samples within 48 hours prior to the proposed movement. And based on all of that information, running a few different scenarios through the model, we could actually only detect about 82% of the infected groups prior to movement, which We obviously still need a lot of work on the risk assessment side to see if that is an appropriate number or not. My gut feeling is that that's maybe not as high as I would have expected to come out of a sampling scheme. So stay tuned on that. That part probably will not be fully fleshed out by the time of the exercise, but just to give an initial starting point for some discussions, even doing that testing and doing observational surveillance, we're not getting a great deal of the diseased animals that they actually detected. So with that, I will turn it over to Tim for the modeling portion.
Okay, thanks, Oriana and Marissa. Good morning, everyone. As was said, I'm part of SIA's modeling team. We are a group of veterinary epidemiologists, economists, and biological scientists who apply models in support of animal health emergency preparedness and response. This morning, I'm going to give an overview of SIA's national ASF model, the population structure that is within it, the disease spread mechanisms, and the control measures that are in the model. And then I'm going to provide some examples of some use cases and recent applications of the model and the types of questions that we are investigating, with the hope that this will stimulate some ideas for how modeling might be useful to those of you who have been working hard at refining and exercising your ASF response plans. The model simulates ASF spread on a national scale among domestic swine premises in the United States. This allows us to explore what-if questions about the potential behavior of outbreaks and the potential effectiveness of different control strategies. It's a stochastic model, meaning that some of its inputs are allowed to vary randomly to reflect either natural variation or uncertainty in certain parameters. And this means that every time you run it, you get a different result, and over many, many runs or iterations, you get a range of results, with the average or the median providing an indication of the most likely outcome, and then at the tails, more extreme events. This is a spatial model, meaning that each swine premises in our population has a point location represented by latitude and longitude coordinates and a number of animals associated with it. The swine population in the model consists of approximately 16,000 commercial premises, 47,000 backyard or small enterprise operations, which we define as those with fewer than 100 head, 1,700 dealers, and 900 swine markets. The model at this time does not include feral swine, although we are exploring options for incorporating that into the model because we know there are a lot of important questions related to the potential role of feral swine in ASF spread. For our model population, we do not have location data for all swine premises in the entire United States. So this swine population is simulated from National Agricultural Statistics Service Census of Agriculture data. This is data that's aggregated at the county level. So the actual locations are then simulated using a smart placement tool called the FLAP tool that was developed by researchers at Colorado State University and people here at SIA. And it uses this county-level data on numbers of premises and numbers of animals to place premises while taking geographic information into account so that they're placed in plausible locations. The swine premises are classified into a number of production types to reflect specialization in the industry. So we have 3 types of sow operations: nurseries, grower finishers. Currently we're working on adding a lean to finish production type. And then we have this other category, too, that can represent things like gilt development units or birth-fed operations. And then we also have production type for the backyard operations. We have also classified the animals on each premises into 4 age categories, depending on what production type it is. And so, for example, a farrow to finish operation will have a certain proportion of its animals be sows, piglets, nursery pigs, or finishing pigs. And this gives us options to investigate some age-specific control measures. This slide shows the locations of those roughly 16,000 commercial swine premises around the United States. We've also overlaid an industry structure on the population that allows us to look at some aspects of the integrated nature of the U.S. swine industry. This structure was created from publicly available information, and it's intended to be plausible, but not exactly to match the real swine industry because the structure is overlaid on an already simulated swine population. this is what it looks like after we have put the industry structure into it. Each color represents a different system, and the light gray points are independent producers, which according to the Ag Census are about approximately 50% of the commercial population. The system structure influences animal movements and contacts between premises via people, vehicles, et cetera, and it can be used to define system-specific control measures. To illustrate the effect of imposing this company structure, this slide shows results when I started a simulation in a large farrow-to-wean operation in North Carolina with no system structure. The results showed that we had a median of 59 infected premises, and the upper end of our 95% confidence interval was as high as 433 premises. And the map shows the percent of iterations where ASF spread to each state. North Carolina says 100% because that's where I started every iteration. When I put the industry structure into the models, this slide shows that the median number of infected premises dropped from 59 to 31, and the upper bound of the confidence interval was less than half of what it was in the previous slide. And it also didn't spread to as many states. The disease spread mostly occurred within the system where it started, although it did escape in some iterations. That explains the population structure in the model. The way the disease is spread in the model is via three general mechanisms. We have movement of animals or direct contacts, movements of people or vehicles, referred to as indirect contacts, and then we have local area spread, which refers to spread that is associated with the distance between infectious and susceptible premises, and it's meant to represent mechanisms that aren't traceable, such as wildlife. The rate of disease spread is influenced by contact rates, so the frequency that each of these movements occurs off of each of the production types, and the probability of transmission, which can be impacted by how long a farm has been infected and the type of movement. This slide shows the general flow of animal movements in the model. We have three sow farm types, farrow-to-wean, farrow-to-feeder, and farrow-to-finish. Those farms, depending on the type, are sending either piglets to nurseries or sending feeder pigs to finishing sites. The nurseries are sending feeder pigs to finishing sites. And then the finishing farms in the other category that I mentioned are sending replacement sows to sow farms. And that's the bulk of the live animal movements within the model, but every production type can send animals to dealers or backyard premises, and animals can change hands through the dealer network and travel long distances across multiple states. We also have markets in the model, and all production types are able to send or receive animals with varying frequencies, and premises can also move animals through swine markets. The model is parameterized right now for a moderately virulent strain. Mariana mentioned a colleague from the University of Minnesota, Sashida Malati, who developed a within-herd model based on experimental data from the Netherlands to estimate individual animal and herd-level disease states and time to detection using a mortality threshold or observation of clinical signs to determine the time to detection. So we've taken the results from that within-herd model and plugged them into our baseline model, and that is currently using a mortality trigger for initial detection. The model is pretty flexible in terms of how control measures can be implemented. This graphic illustrates the baseline control measures that we have in the model right now. During the silent phase spread, passive surveillance based on observation and reporting is the only thing happening until detection occurs. After initial detection, several other control measures kick in, and you still have passive surveillance going on during the response phase. Detected premises are quarantined. Detected premises are depopulated, which can take up to several days. We've implemented a 72-hour national standstill in the baseline that's triggered right away. And then we have tracing of animal movements and most indirect contacts. The effectiveness of tracing is influenced by a probability of movements having been forgotten and are therefore untraceable. And you can set how long it takes to get your trace results. We have also a 10-kilometer circular zone created around detected premises, and then within those 10-kilometer zones, we have movement controls on premises located within them, and then we also have active surveillance on premises within control areas where they're visited every few days. gives you a basic idea of the model population, the mechanisms of disease spread, the control measures. Now I'm going to walk through a few use cases of how the model is being applied, can be applied to support emergency preparedness. And these use cases are related to depopulation, composition of control areas, and movement standstills. Depopulation has been one area of uncertainty. One question that I've heard come up as we work through this ASF exercise series is, just how quickly does depopulation have to occur in order to have an effective response? We can investigate that by varying the time required to complete depopulation on individual premises to see how longer depopulation times impact the outcome of an outbreak. But another question relates to very large operations with many sites. Here's an example of point locations representing multiple sites that belong to one single operation. By classifying them into these operation groups on a limited scale, we can then introduce disease into one or a few of those sites, then investigate the impact of only depopulating the affected sites while leaving the others. Another use case relates to geographic versus network-based control areas, as Oriana mentioned, or some combination of the two. This image is another set of premises zoomed into approximately a county level with the different colors representing different systems. If you have 3 infected premises all belonging to the same system, shown here with arrows pointing at them, and you create 10-kilometer radius control areas around each one, you end up with approximately 140 premises and control areas that are subject to movement controls and permitting requirements and active surveillance requirements. If you shrink the size of the geographic control area to 3 kilometers but include other premises belonging to that system that are shown by the X's, you end up with approximately 23 premises belonging to some sort of control area. At this scale, you may have to include other premises belonging to the same system that aren't shown in this view. But then we can evaluate what's the trade-off between changes in epidemiologic outcomes when you change the composition of the control areas versus placing larger or smaller number of premises in the control areas. What are the impacts to industry of doing that? The last use case that I wanted to describe was related to the potential standstill that has been proposed for the upcoming exercise that could be implemented on a state, regional, or national scale. With the industry structure built into the model, as I described, we can evaluate impact of standstills at different scales given the condition of the outbreak. For example, what type of standstill is appropriate if ASF is detected in a smaller system that operates in 2 states versus a very large system that operates in many states? We can quantify the number of movements that are stopped during the period of the standstill to provide estimates to aid in planning. And we can also vary different aspects of the standstill, such as its length or the time when it is triggered, level of compliance with the standstill. So those are some examples specific to some of the questions that have arisen during the ASF exercises. I also have a few other examples here of ways we've applied the model over the past year, and those are related to providing estimates of lab surge demand, estimates to help with government response cost budgeting, and analysis of economic impacts of an ASF outbreak. Early on, when China first announced that ASF had been detected in that country, we ran some scenarios starting in different parts of the U.S. to provide some estimates of numbers of samples that would be collected for active surveillance during a response. This is kind of a changing situation as the surveillance SOP has been developed and as changes to lab capacity have happened over the past year. But at the time, this graph shows a 5-day moving average of the number of samples per day that would be collected in a medium-sized outbreak and a 95th percentile outbreak. And these results could be used to compare with our estimated lab capacity at the time. We also ran some scenarios to get estimates of the potential sizes of outbreaks, the spatial extended spread to provide information that could be used for budget estimates. This map shows the percent of time that a simulation that started in Iowa spread to other states when the model was run 500 times. And this gave analysts an indication of the number of states that might be involved in an outbreak and resources that might be required to respond. The last example was from a recent economic analysis done by my colleague on the modeling team, Tamina Johnson, to estimate total costs of a response and the economic impacts of an ASF outbreak in the United States. She used outputs from our ASF model as inputs into her economic analysis to come up with these estimates. So I've tried to illustrate the breadth of the types of questions that this model can be used to explore. As we continue to work through these ASF exercises and VS, states and industry continue to refine their ASF response plans, you may come across areas of uncertainty where this model might be able to provide some insight as one tool that should be taken into account with other things like experience and subject matter expertise as a whole. But if that's the case, if you find yourself having some questions or you want to talk through some things that maybe this model could do for you, I've included my contact information as well as that of the Director of the Monitoring and Modeling Unit at SIA, Amy Delgado. So please don't hesitate to contact one of us if you'd like to discuss this further. And that is all I have. Thank you for listening. And please, people on the East Coast, I hope you stay safe during this weather event.
Thanks, Tim. We do have some written questions that I'm going to go ahead and read now. The first one is, for permitting purposes, would you consider the same animals sampled for the 1% zone surveillance the same as those to sample for the 10% premise-specific prevalence? I think that's kind of directed to Oriana.
Yeah, I'm reading through the question. So if I'm understanding it correctly, it's asking if the same animals that are sampled for the zone level detection would count as the same for the premises specific prevalence level. And if we're talking about those premises that are, for example, in the surveillance zone where the 1% would apply, yes, you would. Those are the animals that are sampled at 10% prevalence on the premise level, so trying to detect 10% prevalence on that premise for sampling would be part of the 1%. So it's kind of a nested look at the sampling. The premises would have to do the 10%, and then when we're looking at the number of premises in the zone, we would be looking at 1%. So the 10% would be on that 1% that is selected for sampling in the zone.
Okay. Do we have any verbal questions in the queue?
Well, as we move into Q&A, please feel free to place yourselves in the question queue by dialing #2 on your telephone keypad. You'll hear a notification when your line is unmuted, at which point please state your name and question. Again, that is #2 on your telephone keypad. You can also submit your questions in writing by using the chat box on the right-hand side of your screen. Please remember to select all panelists from the drop-down menu before submitting your question.
We do have one comment that says, thank you for providing this webinar. Good information. And so everyone else knows, we will be, this webinar is being recorded, and we'll be sending out information about where you can find it, so you can pass that along too.
All right, at this time, I'm not showing any other questions. Once again, if you'd like to ask your question verbally, dial #2 on your telephone keypad or submit it in writing using the chat panel on the right-hand side of your screen. Just remember to select all panelists from the drop-down menu before submitting your question.
We do have another question in the written queue. It's, what additional modeling runs can we look forward to seeing to inform our ASF preparedness?
Well, all three of those use cases I mentioned relating to depopulation and control areas and the movement standstill, we have run some scenarios and are continuing to run in each of those areas, and we're hoping to have some results that we can get cleared and released soon, hopefully in the next month.
We have another question come in. I'm interested in the economic impact slide. Can you share assumptions like how long the outbreak lasted, et cetera, for those estimates? It will be interesting to see that slide again, so thanks for posting the webinar and where it will be posted. Do you want to try and bring that back up?
I can bring it up. I'm hesitant to speak to the economic analysis that Kamina did to get these results. Let's see. I can speak to the epidemiologic results. The assumptions about how long the outbreak lasted those are determined by the results of the ASF model, and I don't remember off the top of my head exactly how long they went. If you wanted to contact me directly, I could probably give you that answer. But the analysis that Kamina did then took into account aspects of like how long would trade impacts continue, and she had some assumptions in there too, and I would refer you to her to get more information about the economic analysis.
Okay, we do have another written question. It says, whole blood samples, does additive use happen? Who would address that?
I can address that because I did talk about whole blood samples. I guess I'm not quite clear on what the question is actually asking, so if the attendee that wrote that in wouldn't mind either clarifying that in another written question or opening up their phone line to explain the request, we can address it further.
So at this time, we'll just take another one. It says, follow up to that, will the model be utilized in real time during the functional exercises? An example, the inputs into the model will change during the 4 days based on the state's response.
No, we're not planning to use the model in real time during the exercise right now. I believe that's the way the exercise is structured. There are going to be some jumps in time during the 4 days, and every state, I think, is going to be dealing with a scenario kind of unique to that state. So it would involve running the model simultaneously for many states at the same time, which is a heavy lift.
Another question is there anything missing from the model you wish you could get better data to inform results?
Oh, there's always a need for more data for the model. One of them that I mentioned earlier is on feral swine. That's a really hard one to come up with a feral swine population and then parameters about contact between feral and domestic swine. Also, like I said, our virus strain characteristics in the model are based on data out of the Netherlands, so it'd be great to get some updated data from China or Russia on the behavior of the virus that's circulating in those countries to update those parameters. Always, information on industry, like farm locations from industry or movement patterns within industry are very useful. I could go on and on. Those are probably the biggest areas.
I think that actually answers the one question that came up, did the models take into account feral pig populations?
Yeah, I didn't see that question, but no, we don't have feral pig populations in the model right now, but we are kind of working on how best to add that in.
I think back to the question about whole blood samples that came in through here that says EDTA or heparin use matters with whole blood samples.
I'm not the best one to answer that question. We can direct that to FADL and see if we can get a response back after the webinar.
And we have another written question. Does the modeling for disease spread when considering movement control take into account noncompliance of backyard/commercial producers?
Yes, we can. We can determine the level of compliance with movement controls. And right now, with the standstill that's in the baseline model, we don't have perfect compliance in there. I think we have about 90% compliance for the commercial industry and less than that for backyard operations. And then for movement controls that are within control areas, we can also vary the level of compliance in there and see how that impacts the results.
And we do have an answer from FADL. Thanks, Dr. Mayer. EDTA blood is best for PCR. Heparin blood is used for virus isolation. Hopefully that clears up that question.
Good questions.
Do we have any other questions in the verbal queue?
No, I'm not showing any questions at this time. Again, if you would like to ask your question verbally, dial #2 on your telephone keypad, or you can submit your question in writing by using the chat box. Just remember to select all panelists before submitting your question.
And right now we don't have any more questions in the chat box either. With that, I will thank everyone. Thank you to the speakers that were presenting today, and thanks everybody else for joining today. Our next webinar will be on Tuesday, September 17th. Dr. Richard French will be speaking on his experience with the ASF outbreak in China, and we certainly hope you can join us on the 17th. Have a great day, and hope you all have a nice weekend.
All right, that concludes our conference. Thank you for using AT&T Event Conferencing Enhanced. You may now disconnect.